Hey everyone, and welcome back to This Explainer. I am absolutely thrilled to have you here today because, well, we're going to uncover a piece of modern magic that we all pretty much take for granted. We're going to dissect the everyday miracle of an ATM withdrawal. More specifically, we're going to figure out exactly how a working ATM card actually functions to dispense cash into your hands in the absolute blink of an eye. Okay, let's just dive right into it.
We've all been there, right? Picture this. It's 2 a.m. The street is completely empty, and you have a sudden emergency where you just need cash right now. The bank is long closed, the human tellers are at home fast asleep, and all you have on you is a tiny little piece of plastic. So you step into a brightly lit booth, you insert that card, punch in a 4-digit number, and literally seconds later, exact cash is placed right into your hands. But wait a second, really think about that. It didn't ask for your ID, you didn't fill out a withdrawal slip, so how in the world does this machine instantly know exactly who you are, verify your bank balance, and securely hand over your money without a single human involved? Well, the whole shebang involves this fascinating blend of cryptography, crazy mechanical engineering, and massive global networks.
All right, let's start with Section 1, the origins of 24/7 cash.
It's kind of wild to think that not so long ago, getting your own money meant waiting in endless lines during super strict bank hours. In the 1960s, inventors just started playing around with this wild, out-of-the-box idea of automated cash. And by 1967, the very first successful machine was actually installed at Barclays Bank in London. To the folks using it back then, a machine just spitting out money felt like pure science fiction. Fast forward to today, and millions of these machines are processing billions of transactions globally. They've turned banking into a true 24/7 reality.
Moving right along to Section 2, your card is a key.
Okay, quick misconception alert here. A lot of people, whether they realize it or not, subconsciously feel like their physical card actually holds their money. Let me just shatter that myth for you right now. Your ATM card does not store a single cent, not one. It is quite literally just a digital key. The actual money lives entirely within the bank's digital systems.
And if we look at the evolution of that key, it's pretty incredible. The old school magnetic stripe, that basically just stored really basic, static data. Stuff like your card number and your bank routing info. The problem was, it was super vulnerable because that data never, ever changed. But those modern EMV chips you see on cards today, those tiny little squares of metal, aren't just dumb storage. They act as literal mini computers. Every single time you make a transaction, that chip generates brand new, dynamic security data. It's a real game changer for security.
Which brings us to Section 3, the invisible digital journey.
So the machine reads your chip, figures out your network like Visa or MasterCard, and then asks for your PIN. Your PIN is basically the master password to your digital identity. And thanks to something called the encrypting PIN pad, the exact millisecond you type those digits, they are instantly converted into a highly complex, unbreakable code. Your PIN is never ever stored or transmitted as normal text. Even if a hacker managed to intercept the data straight out of the wire, it would just look like complete gibberish to them.
Now, this invisible journey happens incredibly fast. Your encrypted request leaves that physical ATM booth, travels through massive global network switches, bounces across giant payment networks, and lands all the way at your bank's core banking server. And this entire round trip across the globe, it literally happens in just a few milliseconds.
Once that data hits the bank's server, it runs through this intense, ultra-rapid checklist. It's asking, is the PIN correct? Is the card even active? Does this account actually have enough money in it? Has the user crossed their daily withdrawal limit? Is there any sort of suspicious activity flagged on the account? The server checks off all of these boxes in the absolute blink of an eye. And if everything gets a green light, boom, it fires the approval right back to the ATM.
All right, Section 4, the cash dispensing robot.
Down inside that heavy safe are these cassettes filled with different bill denominations. When the machine finally gets that digital approval, little rubber rollers reach out and grab the exact number of notes required. But here's the cool part. It's not just a blind grab. It is this highly precise mechanical ballet. Internal sensors run a rigorous, on-the-fly inspection. They check the thickness of every single note, the length, the exact position. It can specifically detect if two notes have accidentally stuck together or if a note is torn or heavily damaged.
So what happens if it actually finds a bad note? Well, it uses this brilliant little fail-safe mechanism called the reject bin. Damaged or overlapping notes are just discarded internally. They're literally routed away from the main stack and dumped into a special hidden bin inside the machine. Because of that, you, the customer, only ever receive perfectly counted, crisp notes arranged super neatly on a little conveyor belt.
But wait, the machine's job isn't quite done when the cash pops out of the slot. Have you ever wondered what happens if someone gets distracted, looks at their phone, and just walks away? ATMs actually feature a security retraction system. It actively monitors that cash slot. And if you forget to take your money after a few seconds, the machine will literally yank the cash right back inside itself to prevent it from being snagged by the next person walking by. Pretty smart, right?
Let's look at Section 5, Securing the Mini Banking Robot.
Look, because these machines are literally boxes filled with cash, there is a constant, ongoing war between criminals and banking engineers. Real-world threats like card skimming, hidden cameras, fake keypads, and shoulder surfing, they're always evolving. But these modern machines, they fight back aggressively. They're packed with anti-skimming devices that actively block illegal card readers. They use deeply encrypted communication, CCTV monitoring, and real-time fraud detection systems. It is an absolute cat-and-mouse game out there, but the defenses built into these things today are just incredibly advanced.
And finally, Section 6, the future of ATMs.
So, where are we heading? The next generation of withdrawals is moving toward entirely cardless transactions. We are already seeing huge integrations with apps like UPI, which means you just scan your phone and you're done. Biometrics and face recognition are starting to step in to completely replace the traditional PIN. And honestly, perhaps the most exciting development are cash recycler machines. These are ATMs that don't just hand out cash. They can take the crumpled notes you deposit, perfectly verify them, smooth them out, and literally redispense them to the very next customer. They are basically transforming into fully digital, self-sustaining mini bank branches.
I want you to consider this really profound thought. Technology's true beauty isn't that it's complex, but that it feels simple. I absolutely love that quote. Think about how casually we use ATMs in our daily lives. We slide in a card, mash some buttons, grab the cash, and just walk away without a second thought. Yet behind that incredibly effortless 2-second interaction lies advanced cryptography, heavy mechanical engineering, global banking networks, and thousands of lines of code, all working together in total perfect harmony.
So I want to leave you with this question to ponder today. The next time you hear that satisfying mechanical whir of the ATM dispensing your money, what other invisible digital worlds will you realize are operating right under your nose? Our modern world is literally filled with everyday magic if you just know where to look. Thank you so much for joining me on this explainer today. I really hope you found it as fascinating as I did. Keep learning, stay curious, and I'll catch you on the next one.